Hey there, wherever you're watching from, and whatever hour it happens to be, welcome to Bedtime Universe. Leave your city and the time down in the comments so the stars know where to send their postcards. Now settle in, breathe slow, and let me guide you into a story that unfolded on the quiet edge of our understanding. A story about an interstellar visitor and the small, human moments that met it. They called it 3i, Atlas at first, a tidy tag, for a thing that refused to be tidy. It arrived like a rumor across the gullies and radio dishes of our instruments, a pale whisper against the velvet background of the sky. For days, the feeds filled with numbers, angles, velocities, flux measurements, and an odd, spreading hush that happens when the universe hands humanity a riddle. If you imagine the object as a traveler, then the first thing to know is that it did not rush. Where meteors and comets streaked in quick-handed dramas, 3i Atlas drifted as if reading the pages of the sun's light. It slid into the solar system on an eccentric, unhurried path, its motion traced and retraced by computer models on benches in observatories around the globe. People who study the heavens are a practical lot. They make hypotheses and they puncture them. That is how progress is made, and so hypotheses came first. Pressure from solar photons? Sure, sometimes thin objects slow as sunlight piles up on broad light sails. Outgassing like a comet? Perhaps. A fragment of something tumbling, caught by unseen tides? Possibly. The models said these were all plausible, but observation, patient as tides, said otherwise. It slowed, not once, not in the messy jitter of gas vents, but in gentle, rhythmic pulses. Each pulse matched a heartbeat of its spin. The spectrographs, the instruments that unspooled light into color as one unravels thread, told a second, stranger story. A density less than a tenth of water. Not solid rock, not a dense nucleus. Hollow, perhaps. A shell, a thing with more inside than out. The James Webb Telescope peered at it, and, for a time, all the night sky maps seemed smaller by comparison. We are used to comets with fuzzy comas, gas and dust billowing like poor curtains. Around 3i, Atlas, there was a halo, but it was not ordinary. It glowed a greenhouse green when seen through certain filters, and that glow did not carry the chemical fingerprints we recognized. Some nights, the halo shimmered as if threaded with electric light. Other nights, it lay like a diffidence, a caution against the dark, and there was rhythm. Swift's instruments, quick to catch elusive flashes, reported a precise emission near 497 nanometers. A pure green flicker that pulsed every 22 minutes. Not random noise. Not cellular decay. A metronome. It repeated, patient as tidal breath. When news spreads, it curves the world. Street-side cafes filled with impromptu lectures. Old lovers, separated by years, shared the same headline and felt nearer for it. Schoolchildren made paper models and named them in bright markers. Scientists, the ones with their sleeves always a little peppered with celestial dust, moved like people carrying fragile truths, cautious, thrilled, exhausted. Then came the nights when observatory feeds went silent. Data streams aborted mid-sentence. Schedulers found gaps where there had been none. That is a human drama written in the language of missing zeros and halted timestamps. It made people whisper about control rooms, about intentional curriculums of secrecy. Conspiracy is the shadow cast by fear. It thrives when information contracts and hope inflates. But the instruments that could still see were stubborn. They watched 3i Atlas slow again, and in defiance of many neat equations, nudge its course toward a capture path between Mars and Jupiter. Around us, debate flamed. Capture by gravity or a deliberate change in vector? If a craft could aim, would it loiter in the belt where asteroids ring like dubious sentinels? Or was it choosing a sheltered nursery, a place to rest? There were nights when you could almost expect a word to appear on the dark, a phrase spelled out by the pulsing green. But the sky is not obliged to speak in English. If it speaks at all, it speaks in wavelengths and probabilities, in the elegant coldness of math. So the story turned to the more human elements, the small, stubborn attempts at contact. Messages went up from modest radio arrays in countries that rarely make headlines, sequences of prime numbers, a child's simple song in Morse, a poem recorded at the end of someone's shift. If you think of communication as a bridge, it was as if people everywhere laid down planks, sometimes song, sometimes static, and waited to see if the bridge would be crossed. For a while, nothing came back. Then, in a way that was both subtle and undeniable, instrumentation registered a change in the pulse. The green blink that had been a metronome loosened and stretched, like a hand easing open a fist. There was modulation now, a pattern that mapped not to noise but to structure, a phase within a phase. It invited speculation that was, for once, both scientific and tender. Perhaps the object was trying to understand us, the way a traveler, tasting local words, learns the kindness in a hello. The idea that anything could be engineered by sentience is a heady thing. When the hypothesis surfaces, it draws both the best and worst in us. The wonder of a possible other, and the fearful borrowing of storylines from old science fiction. Many scientists insisted on caution. Extraordinary claims require extraordinary evidence, they said. And they were right. But we are also creatures of curiosity, and curiosity walks like a child down a long, dim hallway until there is an open door. In that hallway lived Aria Thorne, an orbital dynamics specialist who taught with hands that always seemed to be explaining something the fingers had just discovered. Aria did not believe in wonders as a religious act. She believed in them as a procedure. Check the numbers, rerun the model, test the instrument. She lived between equations and nights. Her apartment was a small observatory of mugs and data printouts, a map dotted with coffee stains where she had once spilled caffeinated impatience. Aria had, for years, been studying small bodies that danced too neatly to be chaotic. She loved patterns the way some people loved music. So when the 3I Atlas pulse matched a rotational period and then modulated in ways that hinted at purpose, she stopped sleeping properly. She leaned into the data and let nights unwind into code and graphs. The first time she walked to the window and saw the object through the blind light of the city, she felt the strange sensation of meeting an animal that knows your name. It was not that the object glowed like a city beacon. It was that the world around her seemed quieter, as if the universe had shifted to make room for a conversation. Her colleagues sent messages that were halfway between professional rigor and personal bewilderment. The scientific community is a common language, but in those days it was also a living thing, the way a village shares news by hearth. Labs coordinated. Amateur astronomers in remote provinces picked up the thread. Their little telescopes, like lighthouses for the curious. Someone in a small island nation discovered a frequency offset that tied to the 22-minute pulse. Someone else found micro-variations in light that matched plausible structural reflections. The pattern of discovery was not clean or linear. It was messy and generous, a collaborative art. When the object's path bent toward a more stable orbit, the world held its breath. Imagine, for a moment, a cosmic stranger deciding to lodge itself in our backyard. Planets are practical things. They hold onto objects with gravity's patient fingers, and capture means presence. For some, the capture meant danger of foreign artifact near our homes. For others, it meant company, a chance to study without hurry. Arya argued for restraint and curiosity in equal measure. If 3I, Atlas, carried intelligence, she reasoned, we must be careful not to frighten it. If it did not, we must still treat it as an unprecedented chance to learn. On a moonlit night, she sent a test. Not a shout, but a handshake, a radio sequence of simple mathematical constants, followed by a recording of rain on tin, the sound of home in a universal rhythm. She thought of signals as translations of intent. Answer came not as words, but as nuance. The green blink shifted to match a component of Arya's signal, not copying, but echoing. The echo was garbled, but unmistakable, like the alteration of a song when a new choir learns it. Scientists called it reciprocity. For those who had pumped waves into the dark, it felt like a nod. Rumors blossomed in parallel to the science. Some claimed that agencies around the world were hiding whole chunks of data. Others swore they had seen ships, military vessels, repositioning beneath the quiet sky. People who live by rumor are not always malicious. Sometimes they are simply human, trying to stitch meaning into uncertainty. The truth, like much truth, lodged in a place between extremes. Not all data was withheld, but not all data was shared promptly. Bureaucracy and caution are mortal foils to enthusiasm. It was a woman in the Azores, a retired schoolteacher with a battered camera and a habit of photographing ships at dusk, who caught something everyone else had missed. She sent the picture to a mailing list of enthusiasts and, in the margin of her email, added, I can't prove it, but the light was like the inside of a watch. The photograph showed a faint, comet-like object with an odd shadowing that suggested internal cavities. The internet, as it is wont to do, turned that whisper into chorus. Filmmakers started planning documentaries before the scientific press released full papers. Lovers wrote poems and posted them in small, tender fonts on pages where astronomy and yearning met. The object's green halo continued to puzzle. Spectroscopy suggested the emission might not be chemical at all, but plasma-like, an ionized environment dancing in magnetic loops. Magnetism is the secret path of many cosmic interactions. It can steer dust, it can sculpt the shape of a glow, and most importantly, it can be shaped by the intention of a structure designed to manipulate fields rather than shove matter. Engineers argued that creating a large, light, hollow structure that could exploit stellar radiation or magnetic fields to maneuver was within the bounds of sophisticated technology. The idea was not cheap science fiction. It was engineering stretched to the ambitious edge. The more Arya thought about it, the more she saw the design logic, a shell that trades mass for maneuverability, a surface that learns to whisper to charged particles. If natural processes can mimic some of that behavior, she admitted, the match would still be improbable. Over cups of too strong coffee, committees assembled to plan a measured response. There were proposals for probes, for gentle flybys that would learn composition and structure. Some proposed a more audacious approach. Send an emissary payload that would orbit the object like a small, civil-mannered friend. The plans were expensive, and expense breeds delay, so the world waited and watched. And then, one evening, the object did something that no simulation had predicted. It adjusted its pulse in a way that favored a particular band of radio frequencies, as if nudging an ear toward the human chatter below. The effect was small but symbolic. For the first time, Our collective noise and its green pulse entered an alignment, a patterned duet. For Aria and many others, the moment was less an answer than an invitation. We are wired to anthropomorphize. We love the idea of intent because it gives us the pleasure of recognition. But alongside that human yearning, many voices reminded everyone of the scales involved. Any entity that could travel between stars had a patience whose length mocked human schedules. Our hurry is a short instrument. This thing could afford to wait. It may have no interest in the petty concerns of our politics or our fear. It might have been passing, a mariner looking for a pause in a long voyage. Yet we could not help ourselves. The public began to dream in broad, earnest ways. Artists painted the halo in colors physics could not name. Children insisted that the object be given a friendlier name than 3I Atlas, and so drew stars into letters and called it green light. Newspapers printed speculative editorials alongside op-eds about the need for global cooperation. For a while, the word cosmos took on a softer weight. It was not only distant physics, but a place where something might sit and read our postcards. When the first amateur radio operator, a man who lived with more wires than furniture and had fingers stained by old solder, recorded a reply that mapped to one of his own simple sequences, the logs filled with messages of jubilation. It was not so much that any single person had gained a declarative answer. It was that the sky had admitted the possibility of two-way attention. The world, for a thin slice of nights, felt smaller in the most consoling sense. But with intimacy comes the question of motive, and with motive comes unease. If the object was engineered, who sent it? Where did they come from? Were they explorers, observers, surveyors, or something else? The public conversation shifted, not toward panic, but toward a sober wonder. Philosophers were invited on broadcasts, and poets read in the glow of telescopes. Small rituals emerged in cities. Neighborhoods turned out lanterns one evening and hummed recorded rain, as if inviting a guest into a courtyard. Aria often thought about the object not as an enemy nor a savior, but as an argument. It forced humanity to choose how to behave when faced with the unknown. Would we respond with generosity and curiosity? With territorialism and fear? She wrote papers with painstaking caveats and also tried to write letters to the general public in plain language, urging patience and a thoughtful stance. Science is a method, she wrote, but it is also a habit of kindness toward truth. Careful listening, slow response, an acknowledgement that our models are maps and not the terrain itself. Months slipped like soft coins into a fountain. The object settled into a lopsided orbit, a new permanent sort of visitor sitting between Mars and Jupiter like an unspectacular gate. It did not present open doors or harsh demands. Instead, it continued its steady pulse, sometimes brisker, sometimes more languid. It rotated with the uncanny steadiness of a clockwork animal. In the quiet times, and there were quiet times, long afternoons when nothing seemed to happen, people learned to look at the night again as a shared apparatus of attention. Amateur skywatching groups cropped up in suburbs and urban rooftops. Children learned to identify constellations and the names of telescopes, as if learning the titles of new friends. The flood of conspiracy news slowly ebbed, replaced by slow non-fiction papers that walked readers through methodology and measurement with a human voice. One winter, when the nights were clear and the world smelled of wet pavement, Aria found herself sitting in a small room in the observatory, her hands wrapped around a mug gone cold. She had a folder of printed telemetry and a single line written in a margin by an undergraduate intern in a messy, hopeful script. If they are listening, we should tell them what we love. The thought lodged itself in her like a small compass needle, So she arranged a transmission, not an offer, but an offering. A patchwork of small human things, a set of prime numbers, the notation of a lullaby, the frequencies of whale song, the rhythm of a heartbeat recorded from a newborn in a distant hospital. With permission, the smell of rain approximated in waveform, things meant not to coerce, but to reveal. The message was small and human and oddly brave. It was the equivalent of setting a place at a dinner table and hoping the guest would not mind. For a time, nothing came. And then, in the same way the earth moves and the tide answers the moon, after an interval we cannot perceive until the water is already out, the object modified its green pulse and, in a pattern that was not direct copying but a gentle reshaping, repeated a motif from the lullaby. It was not a translation, it was a reflection. If an answer is a mirror, this was the kind of mirror that yields back what you look like when you are being kind. There are things in the world that change us, not by cataclysm, but by example. The presence of 3I, Atlas, became one of those things. A slow education in how to be patient, how to treat the unknown with a measure of courtesy we had not practiced enough. We made new committees and revised old protocols. We drafted treaties that opened pathways for shared calm. And at the most human level, people sat on rooftops and pointed at the green glow and imagined what the journey must have been like for something to cross the gulf between stars. Years later, when the object had become less headline and more fixture, a child in a small city who had grown up watching the pulses and who had learned to hum the lullaby as one of the minor domestic songs, stood in an observatory with her science fair project and wondered how to say thank you to something that had altered a culture without a single manifesto. She sent a drawing into space on a quiet daytime radio beam, a circle with a dot in the middle, encircled by dots of many colors, an invitation to sit, to look, to be curious. Whether anyone on the object side ever received the drawing is a question that sits patiently in a drawer, marked, might be answered later. It was also the simplest science, taking data and making meaning, converting space between hearts with signals that are at once arbitrary and essential. If you look up now, tonight, from wherever your eyes tilt to the dark, you might catch the faint memory of its green halo, or you might see ordinary stars only. Either is a kind of miracle. The story did not resolve into answers that fit neatly into a textbook. It remained, instead, an invitation to the long practice of learning. It taught us how to wait without paranoia, how to respond without arrogance, how to treat a visitor like a neighbor until it proved otherwise. So when the night deepens and the lamp beside your bed warms the page of whatever you hold, think of this small, steady object that slowed in our sky and pulsed with a rhythm we could recognize. Think of the scientists who stayed up late and the amateur astronomer with the battered camera. Think of that fallen cup of coffee and a note in a margin about what we love. Think, too, of how a world divided by so many small grievances can, for a moment, look up together and be humbled by the strange courtesy of the cosmos. Good night, from Bedtime Universe. If you feel moved, tell us in the comments where you are and what time it is. Let the green light of your place shine in our map, and sleep, knowing the sky is a little fuller, a little kinder, and that we are learning the long, patient language of listening. Good evening, travelers of the night, wherever you are watching from, whether it's early morning, late midnight, or somewhere in between. Welcome back to Bedtime Universe, the place where stories drift like stardust, voices fall like soft rain, and the cosmos opens its quiet pages just for you. Before we begin, tell us in the comments, what time is it where you are? And what universe are you drifting into tonight? Now, breathe in, Let the noise of the world fade away, because tonight we follow a traveler from beyond the sun, beyond every planet we know, a wanderer older than our world itself. This is the story of 3I, Atlas, the interstellar comet that crossed our skies for only a moment, carrying memories from a distant star. Imagine this: far beyond the warmth of the sun, past the orbit of Neptune, past the icy rocks of the Kuiper Belt, past the loose, drifting shells of the hypothetical Oort cloud, and even farther into the starless dark between the stars, something moves. Not quickly, not slowly, simply, eternally. A speck of ice, a grain of stone, a body shaped by silence, sculpted by billions of years of drifting through nothingness. This is 3I, Atlas. Long before the Earth had oceans, long before the moon had fused from molten rock, long before the sun had even finished forming, this wanderer began its journey. Not from our solar system, not from the dust and gas that once circled our infant sun like a shimmering halo. No, 3I, Atlas, was born somewhere else, under a different star, in a different neighborhood of the Milky Way. The star of its birth may be gone now, burned out or scattered by time, but the comet continues onward, carrying whatever secrets remained. For countless ages, the comet drifted. It knew no home. It belonged to no system. It crossed the gulf between suns, the most empty, the most silent, the most isolating space known to existence. Out there, temperature means nothing. Sound cannot travel. Light from distant stars arrives thin and fragile, like the memory of something long gone. But even in the darkness, the comet endured. And then, after perhaps a million years of wandering, it crossed a boundary invisible to any eye except those that measure gravity and the whisper-light pull of stars. It entered the outskirts of the sun's influence, drawn not by invitation, but simply by mathematics. To us, this moment is monumental. To the comet, it is merely another step in an endless, drifting life. Scientists first noticed 3I, Atlas, as a small, faint smear of movement across digital images from the Atlas Survey Telescope in Chile. It looked like any other comet at first, but deeper analysis revealed something extraordinary. Its orbit was not an ellipse, or a circle, or even a stretched-out oval. It was hyperbolic, a trajectory so wide it never curves back. It was not bound to the Sunday. It was merely passing through, a visitor, a guest from the deep. The moment this was confirmed, astronomers around the world adjusted their telescopes, re-aimed satellites, and sharpened their calculations. They had only seen two objects like this before: the strangely tumbling, elongated Oumuamua and the blazing comet 2I, Borisov. Now, 3I, Atlas, became the third messenger from beyond our solar shores. For a moment, the world paid attention, and yet for the comet, attention meant nothing. It did not glow brighter because we looked at it. It did not turn its path. It simply continued. As it approached the inner solar system, sunlight began to warm its frozen surface ice that had been frozen since before human language existed, since before Earth's continents settled into their current shapes. The warmth awakened the comet. Gas vaporized, dust loosened. A coma formed around it, like a soft halo, and a tail unfurled behind it, pulled by radiation and wind from the Sunday. To the human eye, the comet looked alive. To the comet, this was simply chemistry. Observatories on Earth captured images of the growing coma, turquoise hints of ionized gas, white streams of dust, and unstable jets erupting from fractures in the nucleus. Each image was a treasure. The material escaping the comet carried the chemical signatures of a world we would never see. What molecules lived inside 3I, Atlas. What ancient dust had clung to it since the first days of its formation? What clues to alien chemistry waited in the mist? Astronomers worked quickly. Everything about comets is temporary. Every moment is fleeting, and an interstellar comet is the most fleeting of all. While telescopes on Earth observed the comet from afar, spacecraft around Mars caught something rare, a close-up. Against all odds, as 3I, Atlas, passed near the orbit of Mars, orbital spacecraft captured images of its coma, finer, sharper, closer than anything we had expected. Frame by frame, the images revealed jets bursting from beneath the surface, like breath exhaled in cold air. For a body that had slept in darkness for so long, the sun must have felt blinding. Imagine being buried in ice for 1 billion years, then suddenly feeling warmth again. Imagine not understanding why. The comet's surface fractured. Pieces of ice cracked, sublimated, and drifted into the void. Sunlight peeled back layers of material that had not seen radiation in epochs. In the coma, instruments detected water vapor, carbon-based molecules, and fragments of organic dust, tiny hints of chemistry that existed long before Earth's first life took form. Some people wondered, could this mean life elsewhere? The scientists answered carefully. Organic chemistry does not mean biology, but it does mean potential. It does mean commonality. It does mean that the ingredients of life, or of planets, or of atmospheres, may be scattered everywhere, woven into the fabric of the galaxy. If a comet from another star contains pieces of organic material, then perhaps these molecules are not rare at all. Perhaps they are universal. Perhaps the galaxy builds with the same tools in every corner. The closer 3I, Atlas, came to the sun, the more active it became. Its tail stretched millions of kilometers into space, illuminated by solar wind. Its coma brightened. Its nucleus, hidden beneath layers of dust, released more and more ancient vapor. For a brief moment, just a few days, the comet was at its most alive. Scientists call this moment perihelion. Poets call it the comet's awakening, but the universe calls it what it truly is: temperature change. 3I Atlas passed its perihelion near the end of October, at a distance close to the orbit of Mars. Though never visible to the unaided human eye, it was studied intensely by telescopes across the globe and in orbit. Every observation mattered, every frame captured, every spectrum preserved. Because once the comet passed the peak of its encounter with the sun, it began to dim, slowly at first, then faster. The heat slackened, the jets quieted, the coma shrank, the tail scattered into faint wisps trailing behind it. The comet, once awake, began to return to its ancient slumber. From Earth's point of view, this fading felt like the ending of a story. But in truth, for 3I, Atlas, this was simply the restoration of a natural state. The sun was never meant to keep it warm. The inner solar system was not its home. This was just a brief detour, one that the comet would forget as soon as its heat dissipated. Calculations showed that 3I, Atlas, would never return. Its hyperbolic trajectory was a lifelong goodbye. Once it passed through our solar system, it would head toward interstellar darkness again, toward the same silence it had known for so long. Somewhere, perhaps hundreds of thousands of years from now, it may drift into the outer boundaries of another star system. Perhaps it will warm again briefly. Perhaps another civilization millions of years in the future will detect it and wonder, as we did, where it came from. Or perhaps it will drift forever, unseen, untouched, uninterrupted. But here is the strange thing. Even though 3I, Atlas, will forget us, we will not forget it. The data collected from this comet will be studied for years, perhaps decades. The organic signatures in its coma may lead to future discoveries. The unusual chemistry frozen within it may answer questions we have not yet learned to ask. And the simple fact that it came from another star reminds us of something profoundly beautiful. We are part of a galaxy that is alive with motion. Objects travel, systems evolve, stars are born and die. Material drifts between suns, carrying stories older than any language, older than any species, older than any world. We are not isolated. We are connected, even if only by a grain of ice passing in the night. So tonight, as you let your eyelids grow heavy, imagine 3I, Atlas, drifting in darkness again. Its briefly warmed surface freezes once more. Its tail collapses. Its coma fades. It becomes what it was before, a solitary traveler, wrapped in silence, moving endlessly between stars. Imagine the vastness around it, the cold, blue-black ocean of space, dotted with distant suns that flicker like lanterns set too far apart. Imagine the peace of that journey, the stillness, the quiet, so deep it becomes a kind of music. And remember this, for one brief moment, in the endless timeline of the cosmos, our little world, orbiting an average star, looked up and saw a traveler from beyond the sundials, a visitor from the wider galaxy, a whisper from a place we have not yet reached. And though it has already faded into the dark, the story it left behind glows still, not in the sky, but in us. Imagine a silent wanderer drifting through the vast emptiness of space, a frozen relic of cosmic history untouched for billions of years. That was how scientists saw 3I Atlas, a harmless ancient rock, one of countless icy vagabonds born in the dark gulfs between stars. For months, telescopes traced its path with quiet confidence. Equations fit neatly. Its orbit made sense. It was supposed to be just another whisper from the void. And then, without warning, the whisper turned into a scream. On a clear October night, as Mars glowed faintly in the distance, Atlas did something no object in recorded astronomy had ever done. It fired. A sharp, coherent beam of light erupted from its surface, narrow, steady, and impossibly focused, locking onto the red planet like a colossal lighthouse waking from eons of silence. The beam did not scatter or flicker as sunlight reflecting off dust would. It held its aim with mechanical precision, as if guided by intent. For the first time, the cosmos seemed to look back. In that instant, the line separating rock from machine began to blur. Was this a natural phenomenon? Some exotic reaction deep within a comet's crust? Or something engineered, ancient, and deliberate? The equations of celestial mechanics could not explain what happened. No natural process known to physics can project a coherent beam across millions of kilometers. As the world's observatories raced to verify the event, one question began to ripple through the scientific community. What if this was not an accident of nature, but an act of intelligence, an interstellar message written in photons rather than words? If so, then 3 Atlas is not merely a visitor from the stars. It is a mirror held up to humanity itself, asking whether we are ready to recognize when the universe finally decides to answer back. For centuries, comets have been the obedient children of gravity, predictable, graceful, and mathematically tame. Give an astronomer a few days of data, and they can forecast the object's brightness, trajectory, and decay with uncanny accuracy. These icy wanderers are governed by Newton's laws, their beauty bound by the elegance of equations. As scientists monitored its approach, the comet's light curve, that sacred fingerprint of predictability, began to dance erratically. Instead of the smooth, elegant rise expected as it neared the sun, Atlas flared violently, then plunged into darkness, only to blaze again with renewed fury. Its brightness graph resembled not a celestial orbit, but the jagged pulse of a living organism, or perhaps the flicker of a machine running through coded commands. At first, astronomers blamed instrumentation errors, solar interference, even atmospheric distortion. But as data poured in from independent observatories around the world, the same chaotic rhythm appeared. Something profound was happening, something no equation could tame. In physics, unpredictability is not just a nuisance, it is a violation of understanding. When a comet defies the models must change, or the assumptions behind them collapse. Was Atlas venting energy in ways unseen before? Or was it responding to something, perhaps even controlling its own output? The more researchers studied it, the more alive it seemed. The light didn't simply react to solar radiation. It pulsed, as if time. Its surges coincided suspiciously with precise orbital moments, near planetary alignments, or when Mars fell within its direct sightline. In the vast theater of the cosmos, this was not the choreography of chance. It was the rhythm of intention. For the first time, humanity confronted an object that seemed to obey its own laws of motion, guided not by gravity or thermodynamics, but by something deeper, perhaps an intelligence, encoded within its very structure. And if the universe allows such autonomy among its travelers, then our notions of what is natural may soon collapse into dust, replaced by a far stranger truth that somewhere out there, creation itself might be thinking. In astronomy, color is not just beauty, it is truth. The hue of a celestial object reveals its temperature, composition, and chemical soul. Red means iron oxides or organic dust. Green usually signals carbon molecules energized by the sun's heat. These transitions are slow, predictable, and obedient to physics. But 3I, Atlas, seemed to have no interest in obeying anything. When it first appeared in telescopes, Atlas wore the dull crimson tint of an ordinary comet, its surface absorbing light like ancient rust. Then, in a span of mere days, far too early in its orbit, and at a solar distance too cold for chemical agitation, the red faded, and an electric green shimmer burst across its coma. It did not evolve, it transformed. The change was abrupt, surgical, almost theatrical, as if the object had decided to reveal a new face. Astronomers were stunned. The standard explanation, carbon molecules forcing under sunlight, simply failed. The intensity and timing were impossible. No comet had ever changed color at that distance from the sun, and certainly not in such a controlled manner. Some observers described it as though the comet were testing filters switching from one spectrum to another like a machine running diagnostics. If this sounds like science fiction, remember, in science fiction often begins where data refuses to fit. The strange metamorphosis of Atlas raised uncomfortable questions. Could this be a form of photonic signaling? A deliberate use of color as communication? After all, we humans use light in much the same way. Lasers, beacons, fiber optics. Could a civilization advanced enough to cross the interstellar gulf encode messages not in radio waves, but in the spectral fingerprints of matter itself? Even the patterns of his color change seemed oddly synchronized with planetary geometry. Each shift aligned loosely with Mars's position along the ecliptic, as if the object were responding to proximity or attention. To some, this was coincidence. To others, it hinted at awareness. And so, Atlas earned its new title among researchers, the Cosmic Chameleon, a body that bent color not by heat, but by will, painting itself in physics, defying hues, as if reminding us that the language of the cosmos might not be written only in mathematics, but in the living light of intention. If a comet can change color on command, then perhaps the universe itself is less a cold machine and more a stage, waiting for its actors to reveal themselves. For as long as humanity has studied the heavens, one rule about comets stood unbroken: their tails always point away from the sunday. The solar wind, a continuous stream of charged particles, sweeps dust and gas outward, forming the familiar streaming banner that trails behind a comet's icy nucleus. This principle is so fundamental that it's taught in introductory astronomy courses. It is quite literally Astrophysics 101. But 3I, Atlas, did not care for textbooks. When Hubble and the Gemini Observatory turned their lenses toward the object, what they captured was nothing short of heresy against the cosmos. Atlas's tail, or rather its spear of light, extended in the opposite direction, thrusting toward the sun itself. Not a faint illusion or optical quirk, but a blazing, coherent structure that reached across millions of kilometers. It was not drifting, it was aiming. At first, scientists suspected a trick of perspective, perhaps a rare anti-tail, a known but delicate effect caused when Earth's viewpoint aligns with a comet's orbital plane. But this was different. Anti-tails are faint and temporary, mere whispers of dust geometry. Atlas's forward spear was bright, steady, and defiantly symmetrical. It was by every measurement real. The laws of physics had been challenged in open daylight. Normally, light scattered from dust becomes diffuse, soft, fading, and shapeless as it travels through the vacuum. But the beam of Atlas retained its clarity like a laser cutting through the void. Its boundaries were crisp, its brightness unwavering. To hold a beam together across such distances requires control, structure, or intention. Some astronomers began to whisper what others dared not. What if this tail was not a tail at all, but a form of propulsion or transmission? Perhaps Atlas was harnessing solar energy, not fleeing from it. After all, an advanced civilization might not fear the sun. It might feed upon it. Imagine a ship turning its face toward the nearest star, converting radiation into thrust, power, or signal. Even the directionality seemed strategic. The beam's axis lined almost perfectly with Mars's orbit, intersecting the precise region where the planet would pass days later. Coincidence? Perhaps. But the timing, the precision, the geometry, all too deliberate for mere chance. If natural, Atlas represents a revolution in cometary physics, rewriting the very dance between solar, wind, and matter. But if artificial, if this was a deliberate work of design, then we may have just witnessed a demonstration of interstellar technology, older and wiser than our species itself. In that sense, 3I, Atlas, stands as both a scientific riddle and a philosophical one. For when a comet dares to point its light toward the sun, toward the source of all illumination, perhaps what it's really doing is pointing us back to our own ignorance, reminding us that even the most ancient laws of the cosmos may still have authors. In the great symphony of the cosmos, chemistry is the sheet music. Every atom, every molecule plays its part, according to universal laws that do not change from the birth of stars to the icy crust of comets. But when 3I, Atlas, entered the scene, it played notes no one had ever heard before. When spectroscopic readings began arriving from observatories around the world, they told a story that bordered on the absurd. The comet's composition appeared to be roughly 90% carbon dioxide, 9% carbon monoxide, and just a whisper, barely 4% water. For reference, ordinary comets are the opposite, rich in water, ice, dust, and trace carbon compounds. Atlas was, by every definition, an impossibility, a dry comet, burning with unnatural brilliance. It was as though an iceberg had been found, made entirely of vaporized steel. Worse still, deeper scans revealed a strange imbalance between nickel and iron. The inseparable twins of planetary formation everywhere in the cosmos. From meteorites to planetary cores, these metals appear together, forged in the same stellar furnaces. Yet in Atlas, nickel stood alone, eerily pure, with almost no trace of iron. Such a separation is not merely rare, it is unthinkable in nature. Some theorists proposed it had formed in a region of space unlike our own, a star system with radically different nucleosynthesis processes. Others whispered something far bolder. Perhaps the material had been manufactured. After all, industrial refinement, whether human or alien, is precisely the act of separating what nature keeps joined. Then came the most bewildering revelation. When light from Atlas was split and analyzed, it revealed emission lines that did not match any known molecular structure. The spectral signature was like a forged passport, real data, but belonging to no known element or compound. To some, it looked as if Atlas was composed of substances deliberately engineered to avoid easy identification. Even the ratios of carbon monoxide to dioxide defied thermodynamic logic. Under solar heating, those molecules should rapidly equilibrate. Yet Atlas maintained the imbalance with surgical precision, almost like a system actively regulating itself. A feedback loop, a cooling mechanism, a reactor. No one could say. The conclusion was unsettling. Either we were witnessing a new category of interstellar chemistry, or something was maintaining the illusion of one. If this is merely a natural object, then it has rewritten the chemistry of the universe. But if it isn't, if the patterns we see are deliberate, if the separation of metals, the absence of water, and the precise balance of gases are the fingerprints of design, then we are no longer looking at a comet. We are looking at the first known artifact of cosmic engineering. And that changes everything. Not just about what we know of the universe, but about who else might be writing its rules. In every age of science, there comes a moment when the data refuses to behave. When nature itself seems to whisper, "You have missed something fundamental." For 3I, Atlas, that whisper became a thunderclap. Harvard astrophysicist Avi has long been a heretic in the temple of conventional astronomy. He was among the first to suggest that Oumuamua, our first interstellar visitor in 2017, might have been artificial. A light sail drifting through our solar system on alien design. His ideas were dismissed as too bold, too cinematic. But now, with Atlas, the evidence seems to bend once again toward the improbable. Lowe's analysis began where traditional models failed. Why did the object's light fluctuate in rhythmic bursts? Why did his composition defy chemistry? And why did his trajectory appear strategic, skimming close to Mars, yet keeping a safe distance from Earth? To him, the answer did not lie in chaos, but in control. He proposed a hypothesis, both terrifying and exhilarating. 3I. Atlas may be a technological flagship, a massive construct capable of deploying smaller robotic probes as it passes through our solar system. In this view, the sudden spikes in brightness observed by telescopes are not explosions of gas or dust, but controlled emissions. Perhaps the ignition of miniature propulsion systems, or the release of data packets, energy bursts, or even autonomous scouts. Imagine a civilization millions of years older than ours, no longer bound to planets or stars, sending emissaries into the cosmic dark. To them, interstellar travel might not be an act of exploration, but routine maintenance, a sweep of surveillance across young, developing systems like ours. Lowe's theory grew bolder still. He speculated that the forward-pointing beam, the same one that locked briefly onto Mars, might serve as both a propulsion system and a communication channel capable of focusing and directing energy across astronomical distances. The peculiar chemical composition of Atlas, dominated by carbon dioxide and isolated nickel, could then be reinterpreted not as geological oddity, but as engineered materials science, exotic compounds designed to withstand radiation, regulate heat, or manipulate light. The more one examines the data through this lens, the more it fits. The erratic light curves become patterns. The unnatural alignment becomes navigation. The strange silences between bursts become deliberate pauses. Yet Lowe himself cautions humility. In his words, extraordinary claims demand extraordinary evidence, but to refuse to look is the greater failure. For centuries, humanity has gazed outward, expecting to find mere reflections of itself in the stars. Perhaps, he suggests, the universe has finally decided to respond, and the messenger is not a voice, but a beam of light disguised as stone. If 3I Atlas is truly a vessel, then it carries more than metal and mystery. It carries a mirror reflecting our deepest question back at us. Are we alone, or are we simply the last to notice we never were? If the cosmos were a chessboard, 3I Atlas would be playing several moves ahead of us. Its orbit, once dismissed as coincidence, now reveals a pattern of such precision that it borders on strategy. It follows the ecliptic plane, the very thin slice of space where all our planets reside with the near-perfect alignment, as though it chose to travel along the solar system's busiest highway. But the real intrigue lies not in where it goes, but where it hides. As Atlas nears the Sun, it drifts into a position known as solar conjunction, placing itself directly behind the star from Earth's perspective. For several weeks, all our telescopes, ground-based and orbital, lose sight of it. The Sun's blinding glare turns the object invisible, cloaking it in what physicists half-jokingly call the blind spot of God. And it is during this window, according to orbital simulations, that Atlas receives the maximum solar energy, a perfect moment to recharge, recalibrate, or simply vanish from observation. To a human engineer, this would be a tactical masterpiece. Gather power when your observers are blind, then re-emerge with renewed purpose. To a scientist, it is an uncomfortable coincidence that seems too efficient for nature. Avibe and others have noted that Atlas's trajectory not only hugs the ecliptic, but synchronizes its approach to pass near Mars, close enough for detailed observation, yet far enough to avoid interference or collision. Almost like a reconnaissance drone, staying just beyond radar range. Each move appears intentional. Approach, observe, retreat behind the Sun, repeat, and then there's the silence. Since the beam toward Mars, space agencies have gone unusually quiet. NASA, ESA, and China's CNSA have all limited public data releases, citing instrument recalibration or transmission gaps. Yet internal logs, those that have leaked into the scientific community, show no hardware failures, no communication breakdowns. The silence feels less like a malfunction and more like a pause before revelation. If Atlas were a natural comet, its orbital mechanics would simply be the outcome of gravitational dynamics, chaotic but innocent. But if it was something more, then its current position, hidden behind the Sun, shielded from our senses, could be the interstellar equivalent of going dark. In this light, the solar system itself becomes a stage for an ancient play of intelligence and concealment. The Sun, once our symbol of illumination, now doubles as a cosmic curtain. Behind it, Perhaps something is preparing. The physicist in me hesitates to speculate. The storyteller cannot resist, because when nature behaves like a tactician, when a comet acts as if it understands line of sight, power management, and stealth, then we must at least ask who is moving the pieces. Maybe this is nothing more than celestial geometry. Or maybe, just maybe, 3I Atlas has chosen the one place in the universe where even human curiosity cannot yet follow the blinding heart of our own star. On October 4th, 2025, humanity will hold its breath. On that day, the Mars Reconnaissance Orbiter, equipped with one of the most powerful cameras ever sent to another world, will turn its lens toward 3I Atlas. For the first time in history, an interstellar visitor will be photographed not from Earth, but from the perspective of another planet. It is as if Mars itself will open its eyes and look back into the cosmic void. What will we see? Will the images reveal the rough, frozen shell of a comet, obeying the quiet laws of physics, or the gleam of something engineered, deliberate, and ancient? Will we witness the scars of natural chemistry, or the signatures of design, purpose, and intelligence? Each possibility forces us to confront a different version of the universe. If Atlas is natural, then it represents the most complex and confounding chemistry ever observed. A new chapter in astrophysics. But if it is not natural, if this beam and its strange behavior are intentional, then we may be standing at the threshold of our first confirmed encounter with another technological civilization. Perhaps this visitor is not an intruder, but a messenger, one that has been traveling across interstellar space long before humanity learned to walk upright. Or perhaps it is something else entirely. An automated sentinel scanning the stars for signs of awakening minds. A cosmic mirror reflecting our ignorance, or a door to a larger galactic conversation waiting to begin. If you believe that the universe still holds secrets far beyond imagination, then stay curious, leave your thoughts below, share your theories, and join the discussion. And if you'd like to journey deeper into these mysteries with us, like, subscribe, and help us explore the cosmos together, because when the universe finally speaks, we should all be listening.